Good day. I'd like to start by thanking the organizers of this meeting for inviting me to speak. They asked me, in the context of the theme mainstreaming systematic biology for nation building, to share my thoughts about the challenges, opportunities, and future direction of plant systematics in the Philippines. This is challenging for me because, as you might be able to tell from my complexion and accent, I'm not a Filipino. In fact, I have not even set foot in the Philippines since 2018. So I cannot possibly claim to know all that goes on in the systematic botany community in your country. I also don't have the answers to the challenges that systematic botanists face. More importantly, speaking about these topics brings the risk of perpetuating neo-colonial attitudes to science in the Philippines. I accepted the invitation nonetheless because, firstly, I could not resist talking about a topic that I like talking about so much. And secondly, I am in the privileged position to be able to consult about matters of Philippine botany at a daily basis and with a true-blooded Philippine botanist, Dr. Julie Barcelona. Julie is a former curator of ferns at the Philippine National Herbarium. After we got married, we moved to New Zealand, where I work as a plant systematist at the University of Canterbury. However, my interests also cover conservation genetics and other topics related to plant diversity. In recent years, our research has mostly focused on plants in New Zealand and the Philippines. One of the long-term projects that is closest to my heart is Coast Digital Flora of the Philippines. This is a project that Julie and I founded together with Dan Nikrant, a colleague who's currently working at Cornell University. Also known as CDFP, this project aims to provide a comprehensive and continuously updated checklist of all Philippine vascular plants. It is online and free and richly illustrated with photographs. Citizen scientists play an important role in helping us to keep the website up to date, but also to continue our efforts to photo document as many plant species in the Philippines as possible. In this presentation, I would like to start with a brief introduction in which I will argue that systematic botany is an exciting field to work in. I'll illustrate this with a few examples of current research projects in my lab, showing some of the diversity of systematic research that Julie, my students, and I have embraced. I don't want to dwell on this for too long, though, and will then move on to the heart of this presentation and give you our perspectives on the current state and future of systematic botany in the Philippines. It is an exciting time to be a systematist, don't you think? Access to biodiversity data through online portals has never been greater than now. And through these, we have access to a wealth of information. Examples here show Q's Plants of the World online website, but also GBIF is quite important for having access to photographs of herbarium specimens and data. In addition, there's lots of online herbarium databases that can be accessed and plant photograph collections through, for instance, phytoimages. iNaturalist is a great platform for citizen scientists and allows us to collect all kinds of data by a whole army of people. And a wealth of historical information and literature is available to us through the Biodiversity Heritage Library. Further, an enormous amount of genetic and genomic data on GenBank, powerful new informatics tools, pipelines, and work environments, exciting new approaches in molecular biology to generate genomic data, and the drop in cost of doing so make one think that the sky is the limit for a systematic biologist. In my lab at University of Canterbury, we use a wide variety of techniques to better understand evolutionary and genetic patterns and processes. We do this in the field of systematics as well as allied fields. Sojung Kim, for example, is a PhD student in my lab who uses data generated from a 65,000 SNP chip to inform eucalyptus breeding for forestry here in New Zealand. So this is a good example of how applied research can also be of benefit to systematics. And that is because Sojong found that one of his focal species shows unexpected genomic differences, suggesting that it might be necessary to recognize two subspecies for it. Kelvin is a master student in my lab involved in a more what you could call traditional systematics project. He uses very different molecular genetic techniques than Sojong does. Kelvin uses plastome sequencing to resolve the generic delimitation of a New Zealand group of daisies with very complex evolutionary relationships due to ancient hybridization. Ben again uses a different tool set. He uses genotyping by sequencing to understand the genetic diversity and connectivity for the only two known populations of Veronica armstrongia, a narrow endemic here in the mountains of New Zealand. He does this to inform its conservation management. So these are just some examples of projects in my lab that hopefully show you that there's so many different genetic and genomic tools out there that make it really a lot of fun to be a systematist. But let's move on to the Philippines. Using different tools in systematics also has been a focus of our work in the Philippines, after all. Aside from describing plant species new to science in several different plant families and working on CDFP, much of our work has focused on Philippine Rafflesia. These enigmatic and bizarre parasitic plants are a true oddity of the plant world. We used molecular phylogenetic, molecular dating, biogeographic analyses, and population genetic tools to better understand how, where, and when this plant group evolved, and what its biogeographic history is in the Philippines. We also published conservation genetic studies of Philippine Rafflesia species based on microsatellite data, and used these data as well to study species delimitation in a quite difficult group within Rafflesia in the Philippines. This research taught us much about the life history of Rafflesia and its phylogeny, but also about its reproductive strategies and even the evolutionary history of the plants that it parasitizes. Hopefully these examples from my lab show some of the diversity of approaches and data that can be used in plant systematics. But is the sky really the limit for every systematist, or just for a small minority of us? The fast pace of development of molecular biology means that systematists who want to use these tools to address questions in phylogenetics and taxonomy face the challenge of keeping up. For example, not long ago, microsatellites were the preferred tool for resolving species complexes using a population genetics approach. But now, very different genomic approaches, such as genotyping by sequencing, have all but replaced this technology. In addition, with every new technique come new ways to analyze the data. However, these can be difficult to learn and apply, requiring advanced bioinformatics skills. Despite rapidly dropping costs of genetic and genomic analyses, these tools still remain out of reach for many because they are still quite expensive. It's not only expensive to do the wet lab work, with that I mean extracting DNA and preparing libraries, but also data storage and access to powerful computer hardware needed to analyze the data can be prohibitively expensive. In the case of many genomic tools, work with small numbers of samples is just not possible, leaving only space for large projects with large budgets. With finite financial resources available for systematics research, does this then mean larger inequities when it comes to access to funding? More funding in the hands of fewer? In other words, if governments, industry, NGOs, and other funding agencies prioritize funding high-powered and state-of-the-art phylogenomics projects, Does this mean a decrease in the number of institutions and individuals who have the means of advancing the field of systematics? How do communities of systematists, such as ASBP, feel about this? How can they address this? In our view, now is a good time as any to have this discussion, to reevaluate as a community of systematists with an interest in Philippine flora, its biodiversity, evolutionary history and conservation, where we want to be heading and how. How can we empower those of us in less privileged positions? How can we revitalize our fields by inspiring the next generation to become plant systematists? How can we support young career systematists through their education and in their early career stages? How can we benefit from our strengths? Julie and I hope to contribute to this discussion by offering you our perspective on opportunities for systematic botany in the Philippines that, in our view, should at least be considered. But let's start with where we are, the status quo. The vascular flora of the Philippines is composed of about 10,000 species currently known to Western science. It contains about 20% of the total number of species found in the wider Milesian area. So the Philippines is a significant center of plant diversity in Southeast Asia. 51% of its species are endemic to the country. Endemicity at the genus level is fairly low, yet 19 genera, as currently recognized, are only found in the Philippines. About 5.5% of the plant species found in the wild are not native to the Philippines, and they have become naturalized. We know these numbers, well, because we have this continuously updated checklist of Philippine plants in the form of CDFB. Thanks to the efforts and contributions of many, CDFB is illustrated now with more than 72,000 photos of Philippine plants, representing about 48% of the flora. Botanical systematic research published by Filipinos currently focuses for the most part on describing new plant species, like this recently published species of Sororia. One could argue that this has always been the case, because this proud and strong tradition dates back all the way to the days of Father Manuel Blanco and his Flora de Filipinas. Merrill and Elmer were particularly prolific in describing new Philippine species. For example, Merrill described or made new combinations for 2,059 species of Philippine plants that are currently still recognized. Wow. As far as I can tell, Eduardo Quisumbing was the first Filipino to describe a Philippine plant species. He did this together with Merrill in 1928, but starting in 1930, also described several plant species as a single author. In total, he contributed 207 names to the Philippine flora, a remarkable achievement. Especially in biodiversity hotspots such as the Philippines, describing and documenting the flora remains a daunting and important task. But what is different these days is that Philippine researchers, instead of Americans and Europeans, lead the way in describing new species. In recent years, there appears to be a wider diversity of Filipinos publishing new species. Authors now include not only researchers that do botany for a living, but also students, staff working at NGOs, and citizen scientists. Usually, these discoveries are made during opportunistic collecting. In other words, researchers collect and describe new species following chance encounters. But particularly biodiverse and unexplored areas are also targeted with the aim of finding new species. In 2021, 32 new Philippine plant species were described. New species are typically published one at a time, although sometimes in small numbers together in the same publication. Usually a large number of authors is involved, and it is not uncommon that these include foreign botanists. Other fields of systematic botany are less often pursued and by a much less diverse group of researchers. For example, in recent years, publications in which molecular phylogenetic data are presented are almost all coming from one lab or from Filipino grad students working abroad, and then often directly or indirectly associated with this lab in the Philippines. As a result, few plant groups with representatives in the Philippines are exposed to molecular phylogenetic analyses, and few people have opportunities to develop advanced phylogenetic skills. One could argue that this is a logical consequence of existing inequities, because molecular phylogenetic studies can be expensive or at least require access to expensive facilities. However, morphology-based systematic research that does not typically require expensive or specialized equipment, reagents, or services is also seldom done other than in the context of describing new species. Studies using morphometric data sets or other detailed studies using more than a handful of specimens to resolve species complexes or to identify diagnostic characters or understand patterns of morphological variation at the species level or below are surprisingly rare. This slide shows an exception though. This is a study by Jasper Obico, now at UP Manila, that includes detailed leaf morphometric analyses to resolve a complex of Philippine species. Even taxonomic revisions of Philippine plant groups by Filipinos are scarce, and when done, again, mostly so by Filipino grad students overseas. This is an example published this month. It is work by J. Olivar, who's doing his PhD on Sertandra in Leipzig, Germany. Perhaps the limiting factor here for many, especially those not associated with or working in the vicinity of herbaria, is having access to the wider selection of specimens needed for taxonomic studies, particularly when research questions are addressed that require access to type specimens. That's because the majority of its historic type specimens are in overseas herbaria and therefore poorly accessible at best for morphological studies that require access to physical herbarium specimens. However, photos of types in overseas herbaria have become increasingly available in the last decade or so. The impact on Philippine systematic botany here is that assigning electrotypes seems to have become more common in recent years. So, in our view, perhaps the stronger focus on publishing new species rather than on other aspects of systematic botany is on the one hand an indication of the continued need to develop baseline knowledge about the Philippine flora, but on the other, a result of difficulties with pursuing research that requires access to labs, funding, and herbaria. This in turn means fewer opportunities for students and researchers to develop more diverse skill sets that enable a wider diversity of systematic research and, in the case of students, a more diverse range of employment opportunities after graduation. These challenges are difficult to overcome. They really are. We as a systematics community usually have little influence over the funding available to us. However, not all hope is lost. I guess that's one of the main messages of this presentation. Julie and I do believe that progress can be made using a strength-based approach. So if we want to do this, what is the power of Philippine systematic botany? Let's give that some time. Firstly, Philippine plants are by definition present in the Philippines. This means that Filipinos are better placed to collect and study them in their natural environments than foreigners are. There's an immense amount of experience in doing the fieldwork necessary for systematic research, and particularly in the context of finding and describing new species. This includes the logistic skills needed to plan and execute fieldwork effectively and safely, and to navigate the permitting process. Another strength is that there is a social mandate for studying Philippine biodiversity because Filipinos appreciate its significance. This translates to a public interest in plants, such as, for instance, in the context of cultural identity, but also conservation and horticulture. This, in turn, has resulted in a strong citizen science tradition, with people volunteering their time to record and share biodiversity information. This people power source is further strengthened by the large number of biology students throughout the Philippines who are engaged in a wide range of projects as part of their curriculum. This has all resulted in baseline information about Philippine plants that is relatively good and accessible compared to many nearby countries. Our previously mentioned CDFP illustrated checklist is an example of such a resource. It is truly a scaffold and source of almost endless systematic hypotheses to test and knowledge gap that can be filled. There are also some really good examples of effective long-term collaborations that should be mentioned. Collaborations with overseas researchers can be a great strength, a strength that provides access to resources and facilities that are more difficult to access from within the Philippines. The aforementioned masters and PhD students at universities abroad are good examples of this. The Philippines is well placed for such collaborations because of its English language higher education system. There are also good examples of collaboration with local NGOs and other organizations that Philippine systematic botany has benefited from. And of course, when we list strengths, we should not forget the Viva Hot Babes, who contribute to Philippine botany by providing motivation through songs like Bulaklak and other musical masterpieces. Now, with these strengths in mind, opportunities become evident. I'd like to share some of you that Julie and I have identified, but this does not mean that these are not already being pursued or that they are without issues. Firstly, it will be clear from what I discussed earlier that access to Philippine plants for study is a strength. However, this strength remains to be unlocked when it comes to access to plant herbarium collections. To our understanding, there are no publicly accessible herbarium databases in the Philippines. This greatly limits access to the data that herbarium specimens can provide. If you are not in a position where you can visit the Philippine National Herbarium, the herbarium at UP Los Baños, the herbarium at UP Diliman, or one of the very few other herbaria across the country, you simply cannot do much systematic research, or at best, you are severely limited in the type of research that you can do. This is a significant obstacle in the way of developing the diverse set of systematic skills that is required to become a career systematist. It is in fact an equity issue. Therefore, we advocate for a single nationwide and publicly accessible database to which all Philippine herbaria, large and small, can contribute. There's good, free, and open source database software that can be used for this, such as Specify. Ideally, specimens would also be photographed for this database. Cloud-based data storage would ensure that all data is available for all and at all times. By providing rewarding engagement and training opportunities and appropriate respect and recognition, herbaria could also benefit from the help of citizen scientists and students, as is already successfully done in several herbaria. If we truly want to mainstream systematic biology for nation building, this inequity of access to herbarium collections needs to be addressed in other ways as well. We recommend the development of small herbaria with a local focus, suitable to serve the needs for local research projects, where possible aligned with other initiatives such as Tuklas Lunas, and set up to be suitable to serve as teaching collections as well. This would open up systematic botany to a larger and more diverse research community, and also offer greater opportunities for teaching and learning more diverse skill sets. In our opinion, everything should be done to avoid barriers to using such a facility, so that outreach and citizen science can be promoted, facilitated, and included. After all, public interest and citizen science are strengths that we identified, and opportunities to benefit from these strengths should not be missed. Greater access to herbarium collections will provide greater access to a more diverse set of research, teaching, and learning opportunities that have a morphological taxonomic focus. These opportunities are typically relatively low cost. Examples of morphological projects and skills that in our view are underrepresented in systematics in the Philippines include projects that aim to resolve difficult plant species complexes. By the way, such projects are great for teaching students a whole range of transferable skills, including skills in statistics and computer science. Likewise, image-based morphological studies such as outline or landmark analyses provide excellent skill development opportunities. The Philippines would also benefit from studies that identify taxonomically diagnostic characters for difficult plant species, which would make plant identification easier for a wide variety of people. Many species descriptions available for Philippine plants were written a long time ago. They're often very brief and lack diagnostic detail. Therefore, it would be very useful if more studies would focus on using plant collections to amend these older descriptions, to kind of redo them and make them more detailed, updating them with additional information that is now available to us. Herbarium collections also provide opportunities to make plant identification easier by developing good quality scientific illustrations. Strategy at the level of the whole systematic botany community in the Philippines is necessary to take optimal advantage of other strengths, such as fieldwork experience, skills in describing new species, and benefiting from existing collaborations. As mentioned before, little taxonomic revision work is currently carried out compared to work that merely aims to describe new species. For this to be addressed, focus and international collaboration is needed. In addition to increased collaboration between different institutes within the Philippines, we therefore support initiatives that aim to benefit from combining strengths and interests strategically. We especially encourage prioritizing revision work that nicely aligns with in-country taxonomic expertise and that is also well aligned with the interests from society. Projects should be prioritized that allow those involved to use a diverse set of methodologies so that opportunities are created for building diverse skill sets. Alignment with previous revisions is essential. We caution against the common practice of reworking small taxonomic groups that have already been revised as part of the Flora Milesiana project and other contemporary publications. Instead, what we need are collaborative attempts to tackle those groups for which taxonomic revisions have never been carried out. These, however, often tend to be quite challenging and requires that collaboration and sharing of skills. Such projects are therefore likely to require collaborations with institutions and colleagues in nearby countries, such as Indonesia and Malaysia. These would enable access to specimens of species that are essential for revision work, but that cannot be accessed in-country. If interest can be aligned with well-funded institutions abroad, opportunities may emerge to access molecular genetic tools and facilities, and scholarship opportunities for masters and PhD students as well. This has proven to be a successful strategy, but is perhaps not as widely used as can be. Strategic collaborations are also a great way to address geographic or taxonomic sampling gaps. Collaborating, for instance, to go to a particular area that is under-collected and set up a large project to address this issue, or to focus on getting a better set of collections for species groups that are not that well known yet and have not been that studied relatively recently. Talking about low-cost work, things that can be done relatively easily. Well, even without access to molecular genetic facility or money to go and do field work, low-cost work can be done that is rewarding and important, and that provides opportunities to diversify skill sets. As mentioned before, some desktop approaches in systematic botany or allied fields are still quite uncommon in the Philippines, often surprisingly uncommon. One obvious urgent need that can be addressed entirely using a desktop approach is the development of online and multi-entry identification keys to families and genera of Philippine plants. This is a real niche because if you don't know the Philippine flora very well and you don't already know what family or genus a species belongs to, it can be impossible to key your plant out. So multi-entry identification keys can be quite valuable for that because these keys are much more widely accessible and user-friendly than traditional printed dichotomous keys, and therefore offer a great way for students and others to get engaged in systematic botany, to fall in love with plants. The Lucid platform is widely used in New Zealand for this purpose, and apps have been developed that also work on phones even when there is no internet connection. Isn't that great? Species distribution modeling is another approach that is not widely used in systematic botany in the Philippines yet, and what can be used as a way to provide insights into biogeographic patterns, such as island endemicity. When big budgets for large projects are not available, other opportunities to contribute to systematic botany should not be missed. Not having a funded project can also mean being free from meeting deadlines, attending meetings, paying staff, and writing progress reports. In fact, this creates a niche for more sustainable long-term projects that are not forced to end prematurely when the funding period ends. When executed at the grassroots level, such projects can be effective and empowering. They can benefit from the trust and goodwill of society because they often run on a shoestring, not a lot of money involved, and can therefore attract citizen scientists and students. Phytoimages, for example, is the photograph repository that we use for CDFB. This collection of scientifically curated photos is to a large extent built by citizen scientists and students. This works because every photo is a meaningful contribution for which the contributor retains ownership and gets recognition. Such an incremental strategy for building systematic resources and knowledge makes every contribution, no matter how small, count. I think we also should explore developing publicly accessible repositories for work that is unpublished or even unfinished, so that valuable information through the efforts of people does not get lost if a project ends prematurely, or if by itself is not substantial enough to be published in a journal or book publication. The latter category could also include new species records for islands or provinces in the Philippines, maybe even identification keys for small groups of plants that are developed by people as part of their own process of identifying species, but that are not published yet. It could even be a platform for depositing local checklists of plants. We started playing with this idea a little bit. We started developing something like it under the CDFB resource umbrella, with Valsalares from the University of San Carlos contributing an identification key that he made for the genus Atalantia in the Philippines. These and other opportunities don't eventuate by themselves, however. They require work and sacrifices for the greater good, and also looking beyond oneself, both at the institutional and personal level. In order to take advantage of the people power that is needed to advance systematic botany in the way Julie and I see it, the message communicated in this Maori proverb is essential. He aha te mea nui o te ao, he tangata, he tangata, he tangata. What is the most important thing in the world? It is the people, it is the people, it is the people. There's only a future for systematic botany if it is inclusive and equitable. Equality won't be sufficient. In order to grow the impact of our community, we need to work together with equity in mind. Those already in privileged positions, such as colleagues at prestigious universities with tenure and in senior roles, people that are well connected, they have an important responsibility here because the power rests with them. Their success is helping others to be successful. It is not measured by expressing authority in collaborations or insisting authorship on publications. Instead, it is about creating opportunities for less privileged colleagues or students to be part of collaborations and develop leadership skills this way. About protecting junior colleagues from being included in projects as mere field assistants or guns for hire, but that otherwise offer no or little opportunity for growing and building a career in academia. Instead, it is about helping them to find future employment or entry into a PhD program, about valuing mentoring over authorship, but also about helping others becoming their best self by taking the time to provide critical feedback and having high professional standards and expectations. Kindness in science, after all, doesn't mean doing work for others. Likewise, those who have the clout also have the responsibility to make sure that research funding and other investment in people and facilities is equitable, goes where it will empower most. So bringing this together, we see a future for plant systematics in the Philippines that builds on the existing strengths that we listed, particularly using the discovery and the skills in describing new plant species as a starting point, and then expanding to different types of systematic research from there. In order to take advantage of the many opportunities for career development that systematics can provide, the systematics community in the Philippines should focus on diversification. This means diversifying the skill sets that are taught and learned by systematists and students of systematics, but also increasing the diversity of people who have access to these skills and opportunities to advance the field. And also diversifying the type of systematic approaches, techniques, and research questions that are being addressed. I hope to have made it clear that there are many opportunities to make this happen, including low-tech and low-cost opportunities, and also that even small contributions can be meaningful and have impact. However, in order to create this future, access to herbarium collections and associated data should be improved. I mentioned some examples of how this could be achieved. In addition, leadership and strategic collaboration is needed. The type of leadership that looks beyond traditional measurements of success, such as prestige in authorships, academic position, awards, and securing grants. This requires kindness in science, an approach in which professional and personal success is measured by how and how much we contribute to the next generation of systematists. To use this plant analogy, illustrated with this photograph here, a single fruit aiding the dispersal of many seeds. After all, the future is not with oldies like myself, but with people who are considering or who have just started building a career in systematics. Thank you very much for your attention and for the privilege of allowing me to speak with you, speak here at this meeting. I'm looking forward to discussing this further with you and answering some questions